Howdy everyone. This is our proposal for the ESET462 final project, the ball and beam balancing system using PID control. This project will be developed by Avery Betancourt, Ray's Moman, Brandon Fossler, and Matthew Henriquez. This is our overview. The goal is to create a closed-loop control setup that can stabilize a ball or wheel on a beam by adjusting its angle with a motor mounted at its axis, as can be seen in the image below. A position sensor constantly tracks the location of the ball, and then that feedback is used to control the motor in real time. To achieve this, we implemented a PID controller to help keep the ball centered in the beam. The PID controller was chosen because it improves both precision and stability, especially when compared to open loop systems.
Now that we know what the project is, we can go over our plan to complete it. We're going to begin by developing a mathematical model of the system containing the beam and the ball or the wheel. The open and closed loop behavior of the system will be simulated in Simulink. From there, we'll design the PID controller that we'll implement in order to keep the ball or the wheel centered on the beam. The design will be simulated in order to test and verify the performance, where we'll be able to observe potential issues with stability, overshoot, or steady-state error, among other things. We will then move on to building the physical system with the motor attached at the center of the beam. One end of the beam will have an IR distance sensor attached to detect and track the position of the ball. From there, we will use an Arduino microcontroller to integrate the PID controller that we designed. After building the system, we can tune the PID parameters for real-time operation based on the test results and data that we obtain. Finally, we will present our final demo with the system running correctly, and we will use the data from the system testing and the demo to write our final report.
Okay, this block diagram shows the closed-loop control system for our ball and beam balancer. In the next slide, I'll talk more about the actual materials we'll be using for our project. The goal is to keep a ball balanced on a beam by adjusting the tilt with a motor. We start with the set point, the desired ball position, and compare it to the actual position measured by the IR sensor. The difference or error signal is processed by the PID controller, which adjusts the motor position using proportional, integral, and derivative gains. The motor then tilts the beam to correct the position. Disturbances like a push can cause the ball to move, but the closed-loop system continuously adjusts the beam using feedback from the IR sensor to keep the ball at the set point. This system demonstrates how PID control maintains balance and reacts to disturbances in real time. Okay, for our materials, we decide to use a Lego wheel instead of a ping pong ball, and we will also be building our ramp out of Lego pieces. We selected the IR sensor for its accuracy, range, it's within 10 to 80 centimeters, and reliability in tracking the wheel's position, especially compared to ultrasonic sensors. It provides analog output, easily integrating with our microcontroller for real-time feedback. For the motor, we chose the gear motor for its balance of torque and precision. The gear motor provides smooth, controlled movement, which is ideal for PID control, allowing the beam to make fine adjustments without oscillating. This combination ensures precise tracking and stable movement to maintain balance.
Howdy, this is Brandon, and I will be going over the work distribution and timeline of this project. In terms of the work distribution, Avery will be in charge of the project coordination, the system modeling, and the simulation. I will be in charge of the PID control design, tuning, and implementation. Rice will be in charge of hardware assembly, motor, and sensory integration, and Matthew will be in charge of microcontroller programming, real-time testing, and troubleshooting. In reality, we will all help each other with these subjects, but that is who is in charge for each main block. Over the course of the first week, we want to be done with the proposal and the slides, which we are currently doing, and begin the system modeling. Throughout the course of the second week, we want to complete the mathematical modeling and simulate the system behavior, design and simulate the PID controller in Simulink with MATLAB, and gather materials required for said system. Over the course of week 3, we want to assemble the hardware. We want it fully assembled. We want to integrate the sensor and the motor controller with the microcontroller and begin implementing the PID controller in the hardware. Throughout the course of week 4, we want to test and tune the PID controller on hardware, troubleshoot the sensor readings and the motor control, and adjust the parameters for optimal performance. And finally, over the course of week 5, we want final testing and performance evaluation to our satisfaction. We want to prepare the demo setup and the documentation finish the documentation. And then we want to record the live demo and submit the recording and final report.
Next up are expected results. For this project, we expect the ball to stay balanced near the center of the beam, with the PID controller reacting smoothly to any disturbances. We plan to evaluate the system's real-time performance by measuring response time, overshoot, and steady-state error. On the technical side, we anticipate the open-loop system won't correct for the ball's movement. With poorly tuned PID gains, we expect to see oscillations, overshoot, and slower responses. But with properly tuned gains, we're aiming for a quick, stable response that keeps the ball centered. And that is our final proposal. Thanks and gig 'em.